Hello, dear student. Welcome to my class. This is your introductory class. Uh, Today, we'll discuss Introduction to Physics. Okay, Introduction to Physics. And from here, we'll go to Physical World. Okay, we'll see various aspects of physics and physical world. So before start to our course perspective, one question will arise in your mind always, that what do you mean by physics? What do you mean by physics? So, in one word, you can say physics is a knowledge of nature. Physics is a knowledge of nature. So whatever occurs in your nature, that is in your surroundings, there is always physics associated with it. One of the great physicists, Richard P. Feynman, R.P. Feynman, his famous quote is understanding the nature. Understanding the nature. Okay. So now you see something, you observe something in your surroundings, uh, and then you want to express the things. So who will help you in case of expression? Who will help you? Here, one subject, mathematics, will come into this picture, and it will help you to express your thought. So mathematics is a language of physics. Okay, mathematics is a language of physics. With help of mathematics, you can construct a mathematical model or theory to analyze the physical phenomena, whatever is running in your surroundings. Okay, so what are the steps in this way? Whenever you want to analyze or observe the things, so what are the steps? First, you can obviously you can do a systematic observation. Okay, then do some experiment with the help. You can do some controlled experiment. Experiment must be controlled, and to thinking over it, that is your uh, reasoning ability. Okay, and later with the help of mathematics, construct mathematical model, and at last you can verify it or analyze the thing. Okay, whether it is right or whether it is wrong. These are the things which will help you to do your systematic observation, controlled experiment, and reasoning, verification, all of this thing. You know, in physics, there are two types of work there. First, theoretical work, and second is experimental. Experimental and theoretical work can do together, or only theoretical work with the help of some theory, mathematical calculation, everything, it can be do alone. Okay, So these are the things in physics, steps in physics, or scientific method rather say. Okay, so next we will see what are the domains. Okay, what are the domains in physics? Mainly I'm talking about uh, the scope of physics. Okay, in which domain you are wish to working. Mainly there here it is two types of domain. One is macroscopic domain, and second one is microscopic domain. Now, how can you identify what are the domain it is? In macroscopic domain, the term macro is used in a larger perspective. Okay, and the term micro is used in a smaller perspective. Suppose you see in your PDF and you know that if you zoom in, you'll go into the diff that is in your microscopic domain. It's an example. And if you zoom out the things, you will see in a larger perspective. That is it is your macroscopic domain. But in physics, it's different things happen there. Macroscopic domain mainly talks about uh, mechanics, that is classical physics. Classical physics. In classical physics, you know there is a Newton's laws of motion. With the help of it, you can explain those things. Newton's laws of motion. Okay, and some other aspects are there. Thermodynamics is there. Thermodynamics. In thermodynamics, you know, it is associated with internal energy, entropy. Okay, thermodynamic temperature. Obviously, temperature is there. These are all associated with do some external work or external work and transfer of it. Transfer of it. You'll see everything's in detail when the chapter will come. Okay, so don't worry. And there are two others also. This electromagnetism, electricity magnetism associated with charge, charge and magnetic property. Okay, and last one is optics. It is deals with light. It deals with light. So these are macroscopic domain. Okay, it is work in a lab, terrestrial, and astronomical. Okay, lab scale, terrestrial scale, and astronomical scale. This macroscopic domains works. Now, what about microscopic domain? How can you identify that is it works in this domain? Microscopic domain is associated with mainly atomic and molecular types of things. Nuclear phenomena is there. Nuclear phenomena and quantum mechanics also. quantum mechanics also. From here, you can easily introspect the microscopic domain. Okay, and it is your basic knowledge, I think, that particle construct an atom and atom will construct a molecule. It is a basic type of things. Okay, particle will construct atom and atom will construct. So if you analyze in this level, that is in this microscopic level, you can analyze all the things in a whole. Okay, so these are the few things you should know before start. And one more thing I must discuss, that one thing is always in your mind, that what about technology and physics? Some things it comes into your mind, whether technology and physics are same or not. It is same or not. The question is, this is the question, and the answer is obviously not. How can you say that there is a difference? So let's look some example. Okay, here is a technology and here is a scientific principle. What are the principle working behind it? Okay, so first, steam engine. This is technology. What are the scientific principle working? This is laws of thermodynamics. That is, it is associated with thermodynamics. Okay. Second, if you take a nuclear reactor, there are lots of examples there. I'll discuss some of them. Scientific principle behind is controlled nuclear fission reaction. Okay. Next time, if I'm talking about computers, this is logic gate. Okay. If I'm talking about laser, itself a phenomenon that is light amplification of stimulated emission of radiation. Okay. If I'm talking about optical fiber, this is total internal reflection. You know the things. Okay, so there is a difference. You should look carefully that there is a difference. So every technology, there is a scientific principle behind it. So technology is a byproduct of scientific principle, you can say. Okay. So these are the very basic things that I discuss with you, and now I am moving towards some other things also. That is, now I am talking about fundamental forces in nature. What are the fundamental forces? Fundamental forces in nature. What are the forces associated with it? Now, first, one question always come in your mind is why this is called a fundamental? Because they are the building block of this universe. Okay, these forces are building block. So what are they? First, gravitational force. Second, electromagnetic force, and third is the nuclear force. Fourth is weak force. Okay, these are four. I'll discuss a very little to give you an overview of these force. Okay, so first we will discuss the gravitational force. What do you mean by gravitational force and how it is work? So what are the characteristics of gravitational force? That is, it is a force of mutual interaction. Force of mutual interaction due to their masses. Due to their masses. Okay. And second one you can say that is it is non-contact. No need to place one body over another or to get in a contact. And it is independent of intervening medium. Okay, does not depend on medium, whatever be the medium it is. And obviously it's obey inverse square law. Inverse square law. That is force is proportional to 1 by r square. We'll see in details. And it's a long range force, obviously. Long range weakest force. You can say, you can write long range weakest force. Range weakest force. So these are the few things, a few characteristics of gravitational force. Let's take an example. Okay, let's take an example to see all these things in a proper way. Okay, before going to the details, we construct the formula. We assume there's a two body, capital M and small m. Okay, and their masses are situated at the center. Suppose the distance between them is smaller. Okay, so the force is proportional to product of their masses, that is capital M into small m, and inverse squarely proportional to their distance, that is 1 by r square, you can say. Okay, so you can write this F is equal to capital G m by r square, and G is a universal gravitational constant. Okay, from here you can easily find the unit of G and the value. This is the universal gravitational constant, and the value is 6.67 into 10 to the power minus 11, and the unit is Newton meter square by kg square. Okay, so this is the fixed value. Now let's take an example to see the things in a proper manner. Okay, let's assume a two body, that is body A and body B, and take a 3-point in a body particle 1, 2, and 3, and from here is 1, 2, 3. the body A or B are both consisted with 3 particles. Okay, and we treat the system in a discrete manner. Okay, so the force exerted by body A of particle 1 on body B of particle 1, you can say this is body B. Okay, is F11. Okay, the force is F11 and action on this direction. This is F12 on particle 2, and this is on particle 3, F13. Similarly, you can get for particle 2 on the 3 particle of body B. Yes. So here you can get a total 9 component. This is F11, F12, F13. Another one is F21, F22, F23, and for particle 3 of body A to the 3 particles of body B, this F31, F32, and F33. So here you get a discrete forces. If you sum up all these forces, you can get the resultant force. Okay, resultant force. We treat the system in a discrete manner. That is why you will get this type of things. If the body is a continuous, then you should replace the summation over integration if this is a continuous case. Okay, and from here you can get your desired result easily. So these are the overview. How can you get this type of things from your basic knowledge? Okay, now one term you always see in your book, that acceleration due to gravity. What do you mean by this? Acceleration due to gravity, and it is termed as g. This is equals to capital G m upon r square, where capital M is the mass of Earth. Okay, capital R is the radius of Earth, mass of Earth, and this is the radius of Earth. If you and G is a universal gravitational constant. Universal gravitational constant. There is a fixed value, 6.67 into 10 to the power minus 11 Newton meter square by Kelvin square. If you put the value, all of this, M is 6 into 10 to the power 24 kg, G, in case of R, this is 6,400 kilometer. If you put all this value along together, you can get the value of G is 9.8 meter per second square in SI, obviously. And for our simplicity, we take the value is 10. Okay, in order to do our calculation makes easier. Okay, now it's a situation that object of mass m is placed near the Earth's surface. Okay, and the force exerted by the Earth on this object is vertically downward, and the force is m into g. You can easily get that F is equal to m into g, that is g. If you put the value of small g, you can get F is equal to g mm by. Okay, and the direction of the force is vertically downward. So these are the primary things, very basic things. Okay. Okay. Last we will see that how weak the gravitational force is. Let's take a situation. Okay. We take a value capital M and small m, both are in 10 kg. Okay, and the value of r, this is 0.6 meter, and you know z is equal to 6.67 into 10 to the power minus 11 kg meter square, Newton meter square by kg, sorry, kg square. If you put the value all together, you can easily get the value of f. Okay, let's calculate it. 6.67 into 10, for a simplicity you can easily take it 6.7 into 10 to the power minus 11 and put the value of m and n. This is this and 0.6 square. If you calculate this, you can get the order of 10 to the power minus 8. From here, you can easily understand how weak is the gravitational force is. Okay, this later. So this is all about gravitational force in uh, our overview format. And now I'm going to others force as well. Okay, our next force is electromagnetic force. So what are the characteristics of electromagnetic force? Obviously, it is a force between charged particles. Force between charged particles. Second one, you can say that it both repulsive or attractive depending upon the distance. Okay, it depends on medium. It depends on medium. Now you know from your knowledge that in an atom there is a nucleus, and in nucleus proton and neutron along together, and the electrons revolving around the nucleus. Electrons are in a outermost cell. So the force acting between electron and the proton, it is due to the electromagnetic force of attraction. Okay, electron and proton are both in an electromagnetic force. Let's take some example. There are other examples also. You will easily understand how types of force. Let's take an example that force. This is a force between two surfaces. Two surfaces in contact. How can you understand that here electromagnetic force is acting? How can you understand that electromagnetic force is acting here? If you place a book on a table, okay, if you place a book on a table and you know the force exerted by the book on the table is vertically downward, and the force exerted by the table on the book is vertically upward. Okay, so the force acting along the contact between the table and book is electromagnetic force. It is electromagnetic force. Here you can say that the atoms, that the particles, let us say particles of book, or the atoms, molecules. From particle you can go atoms or molecules. and the atoms and molecules of table. Here plays a major role, and the force between them is electromagnetic force. Okay, from here you can draw a concept of friction, that if there is a horizontal component present, okay, then the book on the table did do not slide. Okay, from here you can say that frictional forces act. Okay, so here horizontal component must be present, otherwise friction will not occur. Some other example you can easily see that tension in string or rope. Same things are happen, that electromagnetic force acting here, and force due to spring, force due to spring. Here electromagnetic force also occur. In tension of rope, you know, there is a rope which fastened at two end. Okay, and the force acting here at that point of contact is electromagnetic force, and the electromagnetic force acting at two ends. Okay, and the force of spring, you can, here is a spring. In case of force due to spring, you can compress a spring and you can enlarge the spring. So compression or enlargement is always varies with force is A proportional to delta x. Okay, F is equal to K into delta x, and delta x measures the increment or decrement. Okay, and K is a spring constant. Spring constant. Here the force is all act is electromagnetic force. Obviously, the force due to atoms or molecules of one system to the other system. So these are the overview of electromagnetic force. Okay, now I'm talking about another type of force, that is nuclear force. So what are the characteristics of nuclear force? It is a strong force. It is a strong force. It acts in a very short range. Acts in short range. As a short range force. It's a charge independent. Charge independent, that is the force of proton almost equal to force of proton neutron and force of neutron. It's attractive in nature. It's attractive in nature. Attractive force. So these are the few characteristics of nuclear force. I will discuss in the details when the nuclear physics chapter will be in your topic. Okay, I'll discuss it, and how I will give you some of the overview today about nuclear force. That if I'm talking about helium nucleus, it's alpha particle helium nucleus. Here, two proton and two electron is there. Now tell me one thing: if in a nucleus two proton is consist, Okay, two proton to neutron is a neutral particle, so I'm considering only the proton. Two proton is present here. Now the question here, why Coulomb force is failed to break the nucleus? Is failed to break the nucleus. And other question is it gravitational force to unite the nucleus? So if you want to answer this, you can't. You can't say it properly. You can't say it properly. So that is why here another type of force, that is nuclear force, come into this picture, and with the help of nuclear force you can easily uh, observe the phenomena, you can easily describe the phenomena very well. Okay, and it is very difficult to analyze the force, nuclear force, because it's very extremely short range. It's x over 10 to the minus 15 order. Okay, the nature of nuclear force is very difficult to predict. Okay, but the force here is here act is nuclear force, you can easily see. Okay, and our number 4 is weak force. Weak force, that is beta decay in radioactive nucleus. Here you can consider that neutron converts to proton with electron and antineutrino. Okay, it is a beta minus decay. And in beta plus decay, the proton converts to neutron with help of positron and neutrino. This is beta plus decay. Okay, the force act here is a weak force, very weak. So don't consider that neutron consists of proton and electron and antineutrino. Never consider. It is a conversion. Okay, it is a conversion. I'll discuss all these things in details when particle physics chapter comes. Okay. At last, we will see the strength of this force. The first, you see that the strong nuclear force, and then electromagnetic force, and then weak force, that is beta decay, and at last is gravitational force. Okay, if I'm taking the strength of 1, it is 10 to the power 2 times, 10 to the power 13 times stronger than gravitational force, and 10 to the power 2 times stronger than electromagnetic force. So this is the overview of our introductory class. I'll discuss everything in details when the chapter will come. Okay, so that's all for today. Thank you.